Our project of the thermal machines class consists of the thermal band. The work group is composed by Brian Sanchez, Alexander Rivera, Gabriel Porras, Andrés Ladino, and Diana Cuesta. When we speak of a thermal band, it is known as a continuous conveyor system formed by a wind moving between two rollers. Usually the belt is driven by the friction of the rollers, which at the same time is driven by its motor, and the other drum usually turns freely without the type of drive, and its function is to serve as a return to the band. The web is supported by support rollers. To the moment of the web, the material deposited on the web is conveyed towards the drive drum when the moved rollers and the turns in the opposite direction. The project assigned to work was a prototype conveyor built located in the Thermal Laboratory and Caldas headquarters. Initially it was in the bad condition because its structure was twisted, its control unit and the resistance in bad condition, and even had a transmission so that the band could turn freely did not have the complete suite. Our working group initially analyzed the situation and proceeded to make several changes among the engagement and maintenance on the control unit, the resistance and the implementation of the transmission, which will be explained later.
Mainly the structure of the prototype is 1 meter high by 90 centimeters in length and 40 centimeters wide. It is manufactured at an angle of 1 meter and 1/4, and the band is made on metal mesh. It comes in one of its ends with the electric control, in the center with the resistance box, and the other end with the transmission. The objective of this thermal band in fixing the heat shrink in a assigned piece. In this case, we take a plastic cover lint in heat shrink, and a second example, we take heat shrink through the cable. In order to obtain these results, our group worked initially analyze the situation, and we proceeded to make several changes. Among them, the arrangement and maintenance of the control unit, the resistance, and the implementation of the transmission, which will be explained later. Finally, the arrangements were more aesthetic, such as the loose cables. We'll secure them with moorings so that they were not exposed for an accident, and to make it more presentable, to modify the structure to add more screws and to implement our sanitary band, among others that will be explained with detail below.
The control box. This component is responsible for using the electrical parts needed for the ignition. The resistance of this band is thermal. Its main parts of the following. Number 1. Ignition switch. Is a device that has a function to interrupt the electrical current of the circuit when it exceeds certain maximum values. The device consists therefore on two parts, an electromagnet and heavy metal strip, connect in series and through which circulates the flow that goes to the contact and energizes the system. Number 2. Contactor. and device with capability of cutting the electrical current of the electrical installation of this band. This is connect of the switch and to the controller. A contactor is formed by a coil and some contacts that be open or closed, and which make switch or opening and closing the current in the circuit. Number 3. Controller. It is an instrument used for the regulation of the temperature. The temperature control takes an input from the temperature sensor and has output that is connected to the resistance. In this case, we have a driver on-off to exceed the temperature curve of the board analog disable the system, and the lowering of the temperature provides turns of the resistance again. The chains that we made in this case was the chain of all the wires and had within in a power state. Another chain that took place was the contactor of the which you have was in doing a short in the system. All chain the switch and the of the wound then provide more security of the system.
The thermal box of the conveyor belt is furnace where the heated current enters a resistance head and causes these plastics currents and forms the necessary part. The resistance rises at temperatures of 70 degrees Celsius. The dimensions of the box are 40 centimeters wide, 50 centimeters long, and 30 centimeters high. The resistance is heated by the electric current coming through a cable from the electrical box, and in turn from the mains. The cable is connected inside the box and electrical wrapped in insulation blanket. At the time of this cable to be connected to the resistor, this connection was wrapped white insulation tape before it was in very poor conditions. Also, the side of the thermocouple, which is a temperature sensor, was changed because it prevented the box from opening any operation or maintenance inside. To the box outside was put two supports so that at the time of opening the box has where to rest and not fully open and can be handled correctly. White is respectile handle to open the thermal box in the better way with that can hold from the box, and the operator does not have to wait for the resistance to cool to be able to open the box.
Transmission. Complete band transmission was fabricated using the following: Number 1. Reduction motor. In charge of generating the force to move the conveyor belt with the following characteristics. Power 1/2 horsepower. Speed 50 revolutions per minute. 110 volt alternating current. It also works with a capacitor of 3 microfarads. Number 2. Bushing. Manufactured in steel and machined. It is responsible for joining the motor shaft with the axis of the conveyor belt by means of captive screws. Number 3. Support. Its function is to support the engine and not allow it rotate at the moment of transmitting the torque. It was manufactured with galvanized 16 gauge sheet. It is screwed to the bearing house and the engine. Number 4. Switch. It was installed to avoid having the engine turned on at all times. It is a two-position switch. It was placed on the bottom of the brake so as not to disturb the remaining parts.
This being war will adhere to the piece. This works when the switch of the control module is activated and the racing is started and the air beings. The temperatures reached are between 50 and 70 degrees. A second step is to turn on the switch of the reducer motor to start moving the mesh in which in the entrance will let one of the parts to shrink and when passing through the resting we will find the output with the material head shrunk.